Hi guys. So in this video we are going to talk about the technique that we will use to solve the rotational motion problems. So this is a question that has come in October 2022 International A-level exam of EdXL. So in this question, there is a wheelbarrow. There is a woman which is exerting a force of 80 Newton in the upper direction on the wheelbarrow, and the ground is exerting a force of 320 Newton. And at the center of gravity, there is a force of gravity on the wheelbarrow. Here, in this case, we have to find out the horizontal distance between the center of gravity of the wheelbarrow and the center of the wheel. So let's apply technique here and find the answer. Firstly, we are going to see the acceleration of the body. You see the first three steps are going to be exactly same as we have used in the case of FBD technique for Newton's law problems. So firstly, the three steps will be same. So we will see the acceleration of the body, we will identify the system, we will identify the forces on the body. So here, this is our body, and we can see that the acceleration of this body is zero. So these are the three forces here. Now the next step, the fourth step is different here. Now here what we are going to do, we are going to take a particular point and we will call that point our pivot. You see, it can also be called axis of rotation or origin. Okay, so you can call whatever you want among these three words. So now you see there is a tip that you should remember, that you should be using to identify this axis of rotation. You should take that particular point as the axis of rotation from where the maximum number of unknown forces are passing. You see, if the body is already rotating, then in that case, the axis of rotation is fixed. You know what is the axis of rotation in that case. But if the body is not moving, the body is stationary or in equilibrium, in that case, you can take any point as the axis of rotation, any point as pivot. And it would be better if you take that point as pivot from where the maximum number of unknown forces are passing. So here you can see that we don't know about the force of gravity. So it is our unknown force. So we should take this point as our pivot. Okay. Now next step. After that, we are going to find out the torque due to all the forces about that pivot. So here we are going to find out the torque due to the 80 Newton force, due to 320 Newton force, and due to the force of gravity. Now, the force due to 80 Newton force is going to be 80 into 1.5 minus x. We have applied the formula here. Tau is equals to Fr perpendicular. So this is the formula that we have applied here. The force multiplied by the perpendicular distance of the force from the pivot. Now you should remember that if you find out the torque due to force of gravity, in this case it will be 0 because the R perpendicular here is 0. Now you see there is one more thing that you should remember. If the torque is anti-clockwise, in that case the torque is usually taken as positive, and if the torque is trying to rotate the body in the clockwise direction, then it is taken as negative. Now after that, step 6. In the step 6, we are going to add all the torques. As we can see here, we have added both the torques. And now what we are going to do, after adding the torque, we are going to put the torque as I alpha. Now in this case, because the body is in equilibrium, so here the alpha is 0. So that's why in this case, the value of torque is just going to be 0 only. So we are just going to form the equation. So here we will form the equation and we can easily obtain the value of x as 0.3 meters. Now you see here in this case, we got the answer from just one equation. Many times you will have to form more than one equation to ultimately get your answer. You are going to get the 1 mark for drawing correct free body diagram. You are going to get 1 mark for writing the right formula of the torque and finding out the torque correctly. Then you are going to get 1 mark for forming this equation and then getting the right answer. So in this way, you are going to obtain the marks for this question. Thank you.